This lecture is for a review of significant digits or significant figures. Remember, significant figures are extremely important when reporting a numerical value. When you perform the art of measurement activity, you were determining the number of significant figures in your measurement. How many decimal places should you include in your measurement? The number of significant figures used indicates the confidence or certainty of the value. Now, if you think about the measurements you made, you could be doing a calculation with them, and that's why we need these rules. So, as a reminder, a significant figure is an accurate digit, although the last digit is accepted to have some error. So we had this red line before, and we can call it 7.58. 7 is exact, the 5 is exact, but the 8 is your best guess. And that's where you might vary from your lab partner, all right? So we had to guess that digit there. Uh-oh, bear with me. Okay. The rules. If you've had chemistry, these should sound familiar. So, all non-zero digits in a measurement are significant. All right, someone's made these measurements. You're looking at these numbers saying, how many significant figures are present? 27.92. How many Sig Figs? 4. 678. How many significant figures? 3. Zeros in Sig Figs. Significant digits allow us to systematically express a degree of confidence in a number. The number of significant figures does not include zeros required to place decimal points, which means to give the number the proper value. So zeros fall into 3 cases. Zeros at the front of a number are never significant. For numbers less than 1, zeros immediately to the right of the decimal are not significant. They are important. They give you the value of the number, but we don't count them as Sig Figs. So if we look at those two numbers, in 0.007, only the 7 is significant. In our other number, 0.03401, the first significant digit is your 3. I'm going to draw an arrow. Your 4 counts, you keep counting till the end of the number. So that has 4 Sig Figs. Zeros in the middle of a number are always significant. 23.04. You start counting significant digits from the front of the number. I'll just make little dots. 1, 2, maybe. There we go. 1, 2, 3, 4. If you look at 1007, start counting from the front of the number, first non-zero digit. Each of those have 4 Sig Figs. Zeros at the end of a number are sometimes significant. Zeros placed at the end of a decimal number are significant. So if you remember Pacific and Atlantic rule, if the decimal is present, you start on the left side of the number or the Pacific side of the number, and you count till the end of all the digits. So for 0.700, start counting with the 7, and you count till the end of the number. How many Sig Figs? With 39.030, start with the 3, count to the end of the number because the decimal is present. Three Sig Figs in 0.700, 5 in 39.030. Zeros at the end of the number are sometimes significant. Zeros at the end of a number before the decimal place are never significant. So looking at these two numbers, we have 2,500, no decimal place. I didn't follow this rule a couple pages back, but decimal is absent. Start on the Atlantic side or the right side of the number. Start counting with the first non-zero digit. Let's try this again. So you're not going to count until you get to the 5. Count to the end of the number. So how many sig figs? Looking at 89,400, decimal is absent. Count sig figs from the right. Start counting with the 4 till the end of your digits. How many sig figs? And you should have 2 and 3. Atlantic and Pacific rule. This is just an easy way if you can remember this right and left. Atlantic rule. If the decimal is absent, read from the Atlantic side of the number, and every number starting with the first non-zero digit is significant. If the decimal is present, you use the Pacific rule. You read from the Pacific side of the number, and every number starting with the first non-zero digit is significant. You go to the end of the number. These rules are summarized on your blue handout that I gave you on Friday. So, significant digits. When a number ends with one or more zeros to the left of the decimal, you must indicate the exact number of sig figs. So how many sig figs in this number? Hopefully you're saying 2. Now, what about if we had to express it as 3 sig figs? How could you do that? Hopefully you're saying, oh, scientific notation, that's how I do it. So changing this to scientific notation, you have 3.90 times 10 to the 5th. So the 3.90 gives you 3 sig figs times 10 to the 5th gives you the value. Remember, a positive exponent makes the number bigger than 1. Sometimes that's confusing. How about 4 sig figs? How would you change your mantissa? That's the 3.90 part of the number. Yep, slap on a 0, same value, but now you have more significant digits. Let's just practice some. I have the answers with it. Just counting significant figures. How many sig figs in this number? Yes, 7. How about in 10.2? 3. How about in 0.00304? 3. How about 10,010? 4. Mathematical operations. When you are multiplying and dividing, you want to express your answer with in agreement with the number that has the fewest. So let me read what I wrote. In multiplication and division, use as many significant digits as the number that has the fewest. So let's see what number I have up there. We have 4 kilograms times 4.0. 4 kilograms has 3 sig figs. 4.0 is a measurement. There's 2 sig figs. Your answer should have 2 sig figs. So if you put 16.0, you have the correct value, but you would have too many sig figs. Addition and subtraction. Retain the least number of decimal places of the numbers that you're using. So let's say we have these numbers, 897.0, and we're subtracting 0.922. Go ahead, use your calculator. You get 896.9078. Now, our sig fig rules, think about these as measurements. 7.98 has one decimal place. 0.922 has 3. We need to round to the 1 decimal place. So, our final answer is 896.9, whatever they are. Last slide. If you have to do a combination of operations, perform the multiplication or division first and establish the correct number of sig figs in the sub-answer, and then perform the addition and subtraction, and then round to the proper number of decimal places. That's it for the review. I have one more as a quick one. Nah, this is it. So, if you need more help, let me know.